Now, for this particular sine graph, what I'm going to do is I'm first going to draw y equals sine x, and then I'm going to do my translation. So let's first just draw a simple sine x. So to do that, sine always starts at 0 and goes like this. My normal sine graph has an amplitude of 1. So what you should notice for your normal graph, it should look like this. And you don't want to put too big or anything. You're just trying to get a basic look of sine to start with. All right. Now, this is going to tell us how it's shifting. All right. What you should notice, a negative 1 here means it's going to be going left or right 1. You have to think about which way that is. It's always opposite. So hopefully you can catch on that that would mean we are going to be going right 1 unit. And what does a 2 tell us, hopefully? Up 2. So we know we're going to take this red graph and we are going to move this dot right 1 up 2, right 1 up 2, right 1 up 2, right 1 up 2, right 1 up 2. Each dot is going to go right 1 up 2. Now be careful. Pi, that's about 3.14. Got it? So do you understand 1 is going to be about there? And then that's about 2, and that's about 3. Can you catch on to that? Because pi, you should know, is about 3, think of a 1 length is about 1/3 of the way to pi. So you got to kind of, that's a little trickiness. Because it's not moving by pi's, ones, you have to understand 1 length in terms of pi, which is about 3 units. Now, what is the midline, amplitude, and period? Let's do that before we actually do the shifting. You should notice your midline actually is going to be moved up 2. So you should notice your midline is actually going to be at 2. So let's actually put that. That will help us when we translate it to see the middle of it. Our amplitude, there is no number in the front of sine, so the amplitude is just 1. And your period, there is no number multiplied by the x, so our period is a normal period, which for a sine graph is 2 pi. So our next step is to simply take each of these dots and again go right 1 and up 2. Right 1 and up 2. Right 1, up 2. Right 1, up 2. So for this one, I'm going to be going right 1, which is about, that's about 1, I would say. I'm just guessing. And up 2, there's my dot. Right 1, up 2, there's my dot. Right 1, up 2, there's my dot. Right 1, up 2, there's my dot. And hopefully you can see your graph. Now, hopefully you can also kind of get what the edges look like just by what a cosine graph looks like. Sine graph. Hopefully you know this one's going to kind of start coming back up. And hopefully you can kind of see this one will look kind of like that. So there's our graph. For this graph over here, you are going to start by graphing negative 2 cosine x. And then we're going to shift it this. So hopefully you can catch on that this means we're going to go negative pi, which is, negative would be this way, a length of pi. And then the negative 1 means you're going to be going down 1. You're going to be going down a negative 1 length. But let's first graph negative 2 cosine x. So negative 2 for cosine would start here at negative 2. And then it would go up, hit right there, and then go up to positive 2, and hit right there, and go back down to right there. So let's put some of those dots. We start at negative 2. Normal cosine would start at positive 1, but this is flipped and stretched. So we're starting at negative 2. Cosine always hits right there and right there. And this is stretched up to positive 2 and down to negative 2. And again, it looks like this. And once again, if that was a positive, this whole thing would be flipped over. And if that was a 1, it would be just to here and here, not with up to 2. But basically the 2 stretched it vertically. So that would be the original graph. Now before we go and do the shifting, which you talked about here, we forgot about it. What's your midline, amplitude, and period? So our midline, well, we went down -1, so you should know that your midline is going to be at -1. So let's actually draw that in. I know my new graph, I'm saying, is this graph right here is going to be now centered around this blue line. As we talked about earlier, the 2 here, or the 2 right there, is the amplitude. We don't need the negative, so my amplitude is 2. And there's nothing multiplied on the x, so the period is still 2 pi. For sinusoidal graph, cosine graphs, it is going to be 2 pi. All right, so those are your key features. So now let's shift this red graph so it kind of centers around this, and it's been shifted over pi units. So let's see what pi units look like. And then down 1. So if I take this value, I'd be going way over here. Okay, so I can't do that. This one, pi, oops, I'm off the grid. So I can't do either of these because I'd go off what I have in front of me. But this one, I can go pi over and down 1. So hopefully you can see, if I keep walking over and down 1, I now have that value right there. All right, this dot, I can go over pi and down 1. Oh, okay. So I'm going to go over pi and down 1, and that's where I'm at. Okay, cool. Let's try another one. This one right here we did. Let's try this one. So over pi and down 1. Okay, let's do that. Over pi and down 1. All right. So, sorry, that dot's a little low. That dot should be right there. Oops, because we're kind of going down. My bad. But that one should be up there, so it's right there. Anyways, so you kind of see the graph. The problem is, how do we know what the rest of this graph looks like over this side? Because there's no values over here that I can move over. But you should know what a cosine graph looks like. All right, a cosine graph and sine graphs always have this kind of up-down look. So let's kind of just finish it. We should be able to finish the look of this graph and know it would have that look, because all trig sinusoidal sine or cosine graphs have this down-up look. So that's what it would look like. Now what's really interesting is there was the original. Doesn't it look like you flipped it over? By moving it over, it almost looks like you flipped it over, because this now looks like actually a positive cosine to amplitude graph, but it doesn't. Because of the shifting, it looks like it became different like that. So it's really weird. The shifting, whenever you shift left and right, the H, it really changes the way it looks, and it gets kind of somewhat confusing. So hang in there and try your best.